So I'm going to talk about what we've been doing for the last couple of years on mainly on Kraken, our big Cray XT5 system, and also on the Keeneland system that we help manage for Georgia Tech. As far as having both capability users and people who run jobs that are almost the entire system, at the same time that we have lots of capacity users, people who are using relatively small job sizes, and how we get those to fit together. Let me give you a brief introduction to NICS because we're a relatively new center, and then I'll talk a little bit about Kraken and how we ended up with this bimodal scheduling approach, and then how we took that and applied it to Keeneland, which is a smaller system, a little bit different system, but it's a lot of the same ideas apply. And then I'll talk about what we've been doing lately and what we're going to probably be doing some papers and stuff on in the next year or so. So NICS is the National Institute for Computational Sciences. It's basically the University of Tennessee Supercomputer Center. It was founded in 2007 with the award of the Kraken supercomputer. It's an interesting hybrid. We're all university employees, but our offices and our machine room space is at Oak Ridge National Laboratory. It's a partnership between the university and the lab. We are also part of the Exceed Federation, the NSF's sort of umbrella organization around all of their supercomputing centers. So we do a lot, particularly with Exceed operations, and we run systems for them. Our current set of systems, our flagship machine is Kraken, which is a 100 cabinet Cray XT5 system. She's getting a little old. She's just coming up on 5 years old this month. Then we have Darter, which is an XT30, much smaller system, but almost as powerful. Darter is a 4-cabinet machine that's about a fourth the power of Kraken. It's really striking to walk in the machine room and see the disparity between the two size-wise. We also have Beacon, which is a Cray cluster solutions system that is primarily Xeon Phi based. It's relatively small, 48 nodes, but each node has 4 Xeon Phis. That's primarily a development machine. We have Keeneland, which it's owned by Georgia Tech, but we do the operations for it. It's located in the lab. And that's a GPU-based machine. It's 264 nodes, each with 3 GPUs. And 3 GPUs per node is kind of a weird number, but it's what fits in the packaging. And then we also have Nautilus, which is an SGI UV1000. It's basically a single host with 4 terabytes of memory. So why do we do this bimodal scheduling? Well, for the first few months that we operated Kraken, we were doing scheduling strictly on a priority basis, with the main priority component being the size of the job. And the theory here is, well, the big jobs are the hardest ones to run, so they need the highest priority, and then backfill can fill in all the smaller jobs around it. And that works for the most part. However, when you start going to jobs that are larger than half the machine, you start having to do these long train periods to get enough resources available for that job to run. And unless you have lots of very short-running jobs, backfill will not save you there. And so we have this peak and valley problem where we would have days where we would have very low utilization just because somebody had put in a big job and we were trying to run it as soon as we could. And because of that, the drain time is roughly on the order of the longest job you allow. On Kraken, the maximum job time we allow in most circumstances is 24 hours. So to drain for a big job takes 24 hours, and you lose a lot of cycles that way. And so in 2010, we started thinking about this because our capability users were having to wait a long and perhaps not deterministic amount of time for their jobs to run, Meanwhile, we were getting complaints from the capacity jobs of, hey, why don't, there's resources available, why won't my job run right now? Because they don't look at it as a holistic thing, they look at it as, how soon is my job going to run? It's human nature. So we needed to come up with something that would be a more stable and predictable way of accommodating both of these sets of users, because we had them both, and in the NSF space, at the time, there was really nowhere else for them to go. Kraken was the largest Exceed resource available, and this is 2 or 3 years before Stampede or Waters. So we kind of had a duty to figure out how to do this. So the idea that we went through a couple iterations of how to implement this. The basic idea was we save up all the capability jobs until sometime when the machine is already drained, either after a maintenance window or after a policy determined, okay, we're just going to drain the machine and do a bunch of capability runs. But basically, we chose when we were going to do this. We batch up all of the capability jobs and we run them back to back to back to back to back and go through them all at once. Usually it would be somewhere between 1 to 2 days, and we would do that every week or every couple of weeks, depending on how much demand there was and how often we were doing maintenance. So we had a couple of iterations on this. The last iteration, and the one that we've been using for about 2 years now, uses triggers. So what we do is we attach triggers to some reservations and to jobs to reserve a large set of nodes for the capability jobs, and then adjust things as we move along to make sure that we're not wasting resources, that as the capability jobs get smaller, those reserve nodes that we don't need get released back out so that the capacity jobs can use them. So, and part of the reason we did this was our first iteration of it was completely manual. It involved an admin getting up about once an hour and looking at things, and that doesn't scale very well. I don't like being woken up at 3 a.m. just to do run job on a job. That doesn't work. So we wanted to minimize the amount of human effort that we have to do here. So one thing was we used a reservation profile so that we could set up a reservation and it would automatically have almost all of the triggers that we needed attached to the reservation. So one of the things these triggers did at the beginning of one of these capability reservations, it would turn on the queue that all of the capability jobs land in. So by default, when you submit a capability job that lands in a specific queue that we call capability, we don't have a whole lot of imagination there, and that queue is off. Jobs that are submitted to it by default are not eligible to run. So when a capability reservation starts, the first thing it does is it sets that queue to be enabled, so that jobs are allowed to run. So what this does is it lets capability users get their jobs in. We run through as many of them as we can in a given window, but we've still got resources available, so we can still backfill capacity jobs around it. Sorry, I keep thinking that I need to use the laptop for this. So what we consider a capacity job is anything below half the machine. That's 48,000, I don't remember exactly what the number is, cores. Capability jobs are between 49,000 and 98,352. You're going to say, well, where the heck did that number come from? Well, that is 8,192 nodes plus 4 in case we have some die, times 12 cores per node, because that's Kraken has two STEMBO processors, so it's got 12 cores total. So we actually have another class of jobs beyond that called dedicated. And this is basically the entire machine. We don't do that. We don't have very many of these. Every once in a while, somebody will come along and say, "Hey, I want to do this." But the rough part with dedicated jobs is they tend to be very I/O intensive. Kraken's Celestial file system is a little undersized for a machine of its size, so we only do dedicated runs maybe once a quarter, and only if there's demand for it, because there aren't many users who can scale that big. There's about 24 users that we have that can do capability jobs. Ones that can do dedicated, we have maybe 2. So, to give you an idea of the effect this approach had, this first blue part here, this is what we started with. So you can see it's pretty noisy month to month. We really never get much above, well, okay, we started getting a little above 80% here, but when we started, so here's where we were doing capability scheduling by hand. It's still kind of noisy. Then we started doing what we call defense reservations, where we was blocking off whether or not capability jobs could run on a per day basis. Once we started doing that, notice how the utilization goes up to about 95%. And then we decided, man, defense reservation stuff doesn't work as well as we like. Let's go to triggers. And once we started doing triggers, it's pretty much 95% every month, month after month, until, so Stampede hit the floor here. We still stayed more or less level. Blue Waters came on, so Blue Waters is 10 times the size of Kraken, right? Blue Waters, we drop a little bit and come back up. And then we finally have this dip here. This is where we're having to start telling the allocations process, wait, we can't give you any more hours because the machine's about to go away. That's the only reason this is dropping, is because we're having to start to tail off our allocations. So, as I said, we also run this smaller system called Keeneland for Georgia Tech, and it's 264 nodes. It's an order of magnitude smaller than Kraken. But the PI of the project saw what we were doing with Kraken, and he really liked that idea. He wanted some of his developers to be able to do these large runs that you couldn't really do anywhere else. And so we said, okay, we'll see what we can do to adapt this to a smaller machine, because conceptually it's the same. It's just a matter of scale. There's nothing special about Kraken's 9,400 nodes. It's just the same idea. So one thing we did run into is, in some of the Moab 6 versions, reservation profiles that have ACLs on them, the reservation created from that doesn't get the class list ACL. It was bugged, we found it kicked us in the butt a few times, and then we just finally realized, okay, well, we're going to have to do this by hand. It's just part of our procedures now. And then we had to upgrade Moab on Kraken, and we ran into the same thing there. Yeah, it's not a big deal. It's just something, it bit us a couple times, and then we wrote it up, and we just went on. So, what we're currently working on is, as I said, we'd like to be able to shrink the size of these capability reservations as we go along to accommodate more backfill. We've actually started implementing that using triggers. We'll attach a trigger to each job when it starts to shrink the reservation down to the size of that job. And so you have to be a little bit careful about that. You have to make sure you get the right node list. You have to get the same node list as the job is running on, otherwise you'll have reservations floating around that aren't attached to the nodes that are actually in use. But the big thing we've been working on lately is getting this automated. Even with the reservation profile and trying to minimize the amount of human effort required, there's still 5 or 6 steps to doing this. You have to set up the reservation, you have to manually apply that class list ACL to it, and then you may want to prioritize things in a specific way if the default order isn't quite what you want, and then put the triggers on, and then apply the trigger, another trigger to the last job to drop the reservation. So one of my coworkers, Jesse Hanley, has been working on automating this to the point where it's just capability run, list of job IDs, and everything gets set up for you, and you can just walk away. And that's been pretty successful, and I think we're going to try to get that hardened to the point where we can start looking at giving it to people. Obviously, it would take a fair amount of tuning depending on what your environment looks like, but so I think that's all I have. Does anybody have any questions? Yeah. What's that? So the question was, how would we do this differently on Titan? And let me preface this by, we don't run Titan. That's a DOE system. We don't. I have an account on it, but I don't have any admin rights. We do have a small system that looks vaguely like Titan called Mars. That has some GPUs on it. And the difficulty with doing this on a system like Mars is Mars is actually heterogeneous. It has some XE and some XK nodes. It's kind of like Blue Water's in there. If you started introducing heterogeneity into this, that makes this a lot harder. If you have different node types, that makes this considerably harder. On Titan, it's pretty much everything. They're all the same node type. I'm not really sure what they do as far as jobs that use the GPUs on the nodes versus jobs that don't. You'd probably have to talk to Don Maxwell or Maddie Self or more now. Sorry, I wish I had more information on that. Any other questions? All right, well, thanks for your attention.